we have an exam in Professor A's elementary stats class, and we know that they are normally distributed with a mean of 78 and a standard deviation of 5. Then in Professor B's class, the mean is 77 with a standard deviation of 7. Sally's in Professor A's class while Walter is in Professor B's class, and Sally scored an 86 and Walter scored an 88. Now, just comparing those scores directly, we would say that Walter did better, but we want to look in terms of their respective class. So what we're going to be doing is taking the scores from each of these two students and standardizing them to get a z-score and find out where they would be in terms of the class that they are in, not just overall. So how we get a z-score from a number is we use a formula that says the z is the value x minus the mean mu divided by the standard deviation sigma. So for Sally, her class, Professor A, has a mean of mu equal to 78 and a standard deviation of sigma equal to 5. So if we want the z-score for Sally, we'll take her score, which is 86, subtract 78, and divide by 5. And what we'll get is a z of 1.6. For Walter, we have a mean for Professor B's class, and that is 77, with a standard deviation sigma equal to 7. So if we want the z-score for Walter, we will take his score, which is an 88, subtract the mean of 77, and divide by 7. And what we will get is 1.57. So now that these z-scores are here for us, what we're thinking about is looking at a normal distribution that's now centered at 0 with a standard deviation of 1. And both these scores are now directly comparable. So we could put them on the same graph now. We have a 1.57 and we have a 1.6. And what we're seeing is that the 1.6 is actually better. So in terms of their respective class with the specific mean and how spread out the class's data is, we find that Sally did better in terms of the class.